When designing large passenger ships and tankers, some up to several hundred meters in length, the fuel consumption and propulsion efficiency are critical factors. Conventionally, design of such large ships has relied on performance tests using scale models in large water tanks. This can be time-consuming and expensive. A team at the Shipbuilding Research Center of Japan, in collaboration with Professor Chisachi Kato at the University of Tokyo's Institute of Industrial Science, wants to replace the entire testing tank apparatus with a virtual one using numerical simulations. Their virtual water tank must faithfully reproduce the shape of the ship and, more importantly, the exact water flow around it. Beneath the rear of the ship, a rotating propeller pushes the ship forward. But the way the water flows into the propeller can significantly impact its efficiency. So for design purposes, it's crucial that the virtual water flows like the real thing. But complicating the design process, along the hull of the ship, tiny swirling eddies, less than a millimeter in size, can form anywhere the hull surface meets the water. It's been practically impossible to reproduce these sub-millimeter eddies all along the hull of a large ship. With Fugaku, they're aiming for a virtual testing tank that faithfully recreates these tiny eddies, along with all the shapes of the ship's hull, propeller, and rudder.
単純に言えば一つは受験をする、あるいは試験をするお金がいらなくなるということもありますし、それから試験の準備の時間もいらなくなると。ただもっと大きな目で言うと線形を設計したら、直ちにその線形に対する性能が評価できるので、そのものづくりのスピード自体を飛躍的に速くすることができるという点が一番大きなメリットと考えています。